In order to design the architectural element that does its intended functional purpose without using excessive embodied energy, we need to understand what it takes to achieve the intended agenda based on the scientific understanding to design the right shading elements. According to the Department of Energy, lighting consumes 40% by commercial buildings. About half of all that electricity could be saved by daylighting the building. But we also noticed that 30% of heating and cooling also takes a great amount of energy. In general, we should shade the building in order to prevent the building from being overheated. The shading should also play a role of protecting people from disruptive glare. At the same time, the architect should bring the maximum amount of the usable daylight, through which will reduce the electric lighting energy for the building. Based on the size and program of the building, we can divide them into two different types and approach it separately. Usually, residential buildings or single-story office buildings are considered to be envelope-dominated type, which is relatively more heating-dominated. However, buildings such as high-rise office buildings and auditorium where more amount of internal heat is being generated inside and the envelope to floor area ratio is lower, in other words, more compact, we consider those buildings to be internally dominated buildings. Internally dominated buildings tend to be cooling dominated unless the building is located in the extremely cold portion of the globe. As we've discussed earlier, thermal performance should be considered in parallel with the daylight performance, and controlling these two variables at the same time requires intensive design effort. Orientation is critical part during our shading design. The graph on the left shows the daily solar radiation received for each of 5 different orientation. For example, this is horizontal surfaces daily solar radiation received from January to December, and this is the north facade daily solar radiation from January to December, and this is south and east and west together. Here's the question. Based on this graph, which window orientation needs the most shading in the summer? The graph shows that on June 21st, a horizontal skylight of the roof received the greatest amount of solar radiation. Therefore, the horizontal surface where the skylights are located needs an effective solar shading during the summertime. If shading is the main concern and passive heating is not required, then a fixed overhang may be used. If both passive heating and shading are important, then a movable overhang should be used. This chart is a comprehensive chart showing a range of conventional architectural shadings desirable for different orientations, which is useful to be referenced during the design process. This diagram shows both the sun angle at the end of the overheated period, as well as the cold period with the lower winter sun angle. Even though the current position of the overhang position is optimal for blocking the summer sun, it seems to be vulnerable for the lower winter sun angle, and it seems to be creating a glare discomfort for the users inside during the winter. The shading should be adjusted based on locating the optimal overhang position to address the low winter sun as well as the summer sun. When overhangs are higher on the wall, and that extends to a full shade line, will still block the direct radiation, and yet a larger view of the sky is provided for the interior users. However, this would not be desirable in regions with significant diffuse radiation coming from many different directions. In this case, the use of shorter shading geometry while increasing the frequency of the shading geometry is better despite some compromise of the clear view towards the outside. Now let's look at the reference projects. This is the Red Build building in Philadelphia designed by Louis Kahn. On the southern face of this building, which is a hospital addition, the architect Louis Kahn designed the overhang for each floors, which differentiate its depths in respect to the floor-to-floor height. Based on examining the wall section of this project, it is clear that through the design of the overhang, the architect is blocking out most of the direct solar throughout the most of the year, while providing the clear view toward the outside for the patients inside. And this is the Queen's Enclosure School in England, designed by Sir Colin Stanfield. This building not only blocks the southern sun to achieve the maximum visual connection from inside to the outside, but also redirects the light in the northern facades using the same perforated louver detail back into the northern facade of the building. The Seinäjoki Library, located in Finland, designed by Arva Aalto, uses the dense architectural louver on the high portion of the south side of the building. The strategic location of these louvered high windows, in combination with the curved ceiling, which redirects the light down to main library space below, while preventing the direct solar ray reaching into the books, preventing it from deterioration. East and west facades are more related to the solar ray that is reaching during the morning and afternoon. During this time, the sun's motion is more horizontal compared to the midday. Switching to vertical fins perform better if the geometry is properly designed based on the dominant solar angles. However, east and west facade should also address the altitude angle of the sun at the same time by adding the horizontal shading or morphing the vertical shadings. As discussed, various forms of vertical shadings are being used for east and west facades. For reference to address the east and west facades, this is a good example. It's called the Mill Owners Association by Le Corbusier. The architect used the carefully designed écrit language in multiple projects to address the east and west solar treatment. This Mill Owners Association building shows the écrit on its western facade in reaction to the angle of the day's afternoon sun, while embracing the diffuse solar daylighting entering into the building. For the Consorcio Vida offices located on the Conde Santiago of Chile, designed by Edificio Consorcio Santiago, this building uses the vegetated wall that is detached from the window to protect the west facade from direct solar radiation, and in the result, it introduces the biophilic design approach for the office space inside.